You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Decomposition in Agile practice is the art of transforming large, abstract initiatives into smaller, manageable pieces of work that can be delivered incrementally. At its core, decomposition orients a team toward delivering value earlier, learning continuously, and reducing the uncertainty that naturally comes with ambitious goals. A large idea, such as a sweeping digital transformation feature or a major customer-facing capability, can feel daunting in its entirety. Without thoughtful decomposition, work piles up in ways that delay feedback until late in the cycle, often leading to costly rework. Instead, Agile teams focus on thin, end-to-end slices pieces of work that are small enough to complete in a short cycle, yet meaningful enough to validate assumptions about behavior, integration, and acceptance. Decomposition is not about chopping blindly but about preserving intent while creating a predictable flow of delivery, where each increment advances the larger outcome safely and visibly. An epic represents a large-scale outcome or capability that cannot be realized in a single iteration. Think of it like a novel. No one expects to read or write it all at once. Instead, it unfolds chapter by chapter. Epics may span multiple increments, or even entire releases, and they act as containers for related stories that collectively deliver on the broader objective. Decomposition of an epic becomes essential when the size, scope, or uncertainty makes progress unpredictable. Teams may recognize the need to decompose when cycle times stretch too long, when dependencies with other teams or systems create bottlenecks, or when the level of coupling between components makes integration risky. Breaking an epic down provides a way to deliver visible progress early while keeping the larger intent intact. This way, learning, feedback, and adaptation are possible long before the epic is considered complete, making it a practical and risk-aware approach. A central principle in decomposition is the contrast between vertical slicing and horizontal slicing. Horizontal slicing means dividing work by layers, such as database, middleware, and interface, without producing a usable feature until all the pieces are assembled. While natural for specialists who work within these layers, horizontal slices defer value because nothing functions fully until the end. Vertical slicing, by contrast, creates thin end-to-end flows of functionality. Even if minimal, these flows deliver observable value to a user or measurable outcomes in a system. For example, instead of building all database tables first, a vertical slice might provide a single, working "add item to cart" flow in an e-commerce application. That flow spans interface, logic, and storage together, demonstrating integration and acceptance in one step. The vertical approach validates assumptions earlier, uncovers integration risks, and produces feedback faster. Agile practices favor vertical slices because they prove value continuously, not at the last minute. The thin slice principle builds directly on vertical slicing by emphasizing the smallest coherent unit of behavior that can be delivered meaningfully. Coherence is vital here. A slice is not simply a fragment of work, but a complete, testable experience, no matter how small. Teams often ask themselves, what is the smallest piece of functionality a user could touch, or a system could verify, that would still provide learning? For instance, in a flight booking system, instead of waiting until search, booking, and payment are all implemented, the first thin slice might only allow searching for available flights. That alone is valuable because it can be demonstrated, tested, and validated in real use. Thin slices accelerate delivery by producing feedback sooner and encourage teams to release usable increments rather than half-finished parts. By continuously shipping slices, teams shorten the distance between idea and evidence, which is the foundation of Agile learning. Workflow step splitting offers another structured way of breaking work down by mapping directly to the user's journey. Every user flow has natural stages: discover, select, confirm, complete, and each stage can be decomposed into a separate testable slice. For example, in an online grocery ordering system, a team might first deliver the discovery phase, allowing users to browse products. That slice alone provides functional value and can be validated in production. Next, the selection phase adds the ability to choose items, followed by confirmation and checkout. Each slice represents a usable stage of the journey, meaning users are always seeing progress while the system gradually becomes more capable. Workflow step splitting is powerful because it ties decomposition to the way users actually think and behave, ensuring that increments are meaningful rather than arbitrary. It reinforces the principle that software should evolve through working, observable outcomes rather than long waits for full completeness. Business rule variation splitting addresses the reality that most systems operate on both simple, happy paths and complex sets of rules or exceptions. Attempting to implement all rules simultaneously can overwhelm teams and introduce unnecessary risk early. Instead, decomposition begins with the core rule set, ensuring the basic path works reliably. For example, in an insurance claims platform, the team may first handle straightforward claims that follow the standard process. Once that flow is stable and validated, they can then add exception handling for rare but complex conditions, like claims involving multiple policies or fraud checks. By isolating business rule variations into later slices, teams protect delivery of the core value and avoid stalling progress on edge cases that only apply occasionally. This incremental approach also means exceptions are validated in isolation, reducing the chance of introducing instability into the central user experience. It's a pragmatic way to manage complexity without losing momentum. Data dimension splitting is particularly effective in systems where data types, ranges, or formats introduce complexity. Rather than attempting to handle every possible data scenario at once, decomposition starts with the most common or representative cases. For example, a banking application might begin with standard deposit transactions in US dollars before expanding to large transfers, international currencies, or unusual edge conditions like negative balances. This approach provides confidence early that the system functions correctly for the majority of cases, while deferring high-risk or uncommon scenarios until later increments. Data dimension splitting creates an incremental path to robustness, where each slice gradually expands coverage. By sequencing this way, teams build stability first and complexity later. It also allows learning about performance or security implications of typical cases before stretching the system into boundary conditions. In this sense, decomposition becomes a way of pacing risk exposure while steadily extending capability. Interface and channel splitting recognizes that systems often present multiple entry points for users and partners' application programming interfaces, web interfaces, mobile apps, or even batch processes. Attempting to deliver all channels simultaneously increases coordination overhead and delays. Instead, decomposition targets one channel at a time, creating progress that can be validated without waiting for everything to align. For example, a development team might first deliver a functional API for partner integration, then follow with a web front-end, and later a mobile experience. Each slice validates assumptions about design, usability, and integration for one channel before spreading to others. This sequencing reduces risk, avoids wasted effort in synchronizing across platforms, and allows feedback from the first channel to inform later implementations. Interface and channel splitting illustrates that smaller scope often means faster delivery, clearer learning, and better quality, even if it requires discipline to defer parallel builds. The SPIDR pattern offers teams a simple yet effective mental model for decomposition. The acronym stands for Spikes, Paths, Interfaces, Data, and Rules. Each category represents a different angle for slicing. A spike is an exploratory effort designed to answer a question or test an assumption. Paths represent user workflows. Interfaces refer to the channels through which functionality is accessed. Data emphasizes conditions, ranges, or formats. Rules address business logic and variations. By keeping SPIDR in mind, teams avoid narrowing decomposition to just one type of slice. For instance, when working on a new billing feature, They might first run a spike to evaluate third-party integration, then implement a basic payment path, followed by a web interface, typical data cases, and finally rules for discounts or refunds. SPIDR keeps decomposition outcome-oriented, ensuring slices remain aligned to real functionality instead of devolving into disconnected technical tasks. Persona or job-to-be-done splitting grounds decomposition in the needs of specific users. Instead of attempting to design for all personas simultaneously, teams focus on one archetype first, ensuring that their most important or frequent users see value earliest. For example, a hospital software team might prioritize workflows for nurses before those for administrators or executives, since nurses interact with patients most directly. Delivering value to one persona validates assumptions, provides actionable feedback, and creates a strong foundation before extending to others. This technique prevents teams from spreading thin across multiple competing demands and ensures progress remains visible. It also sharpens understanding of what done means for real users, as each persona's slice can be tested in real scenarios. In this way, decomposition becomes not just a technical strategy but a customer-centric one, aligning delivery order to actual priorities in the field. Non-functional slice selection is an often overlooked but critical aspect of decomposition. Too often, teams focus only on features, leaving qualities like performance, security, and operability until late. This deferral creates painful surprises at release when the system suddenly fails under load or fails a security audit. Decomposition that pulls non-functional concerns forward avoids these risks. For example, a streaming service might include an early slice that measures concurrency by simulating hundreds of simultaneous users. That slice is not about new functionality, but about proving architectural assumptions under realistic conditions. Similarly, a thin slice may test encryption or response times early. By treating non-functional slices as first-class citizens in decomposition, teams balance the visible and invisible aspects of value. They ensure that quality is baked into each increment rather than bolted on at the end, reinforcing agility through continuous confidence. Dependency-aware slicing tackles the unavoidable reality that many features rely on external systems or teams. Waiting for dependencies to mature before making progress can stall momentum and waste opportunities for feedback. Instead, decomposition deliberately decouples work by using stubs, mock services, or contract tests that simulate the behavior of external systems. For example, while waiting for a payment gateway to go live, a team might create a stub that mimics expected responses, allowing them to validate their checkout process in parallel. Later, they replace the stub with the real integration. This strategy keeps flow moving, surfaces integration risks earlier, and avoids last-minute surprises. Dependency-aware decomposition acknowledges that while teams cannot eliminate dependencies, they can manage them proactively. By isolating and sequencing external risks, teams preserve progress while still preparing for eventual integration with real systems. Definition of ready alignment is the final safeguard that ensures slices are actionable before development begins. A slice that enters the workflow prematurely can create churn, rework, and frustration. Aligning to a clear definition of ready means each slice has context, acceptance criteria, identified risks, and even telemetry considerations before work starts. This prevents cycle time variability and allows teams to deliver consistently. For example, before beginning development on a new add-to-wishlist feature, the team ensures they know the acceptance criteria, potential error states, and how they will measure usage once released. With this clarity, developers, testers, and stakeholders share a common understanding of what done will look like. Decomposition without readiness is like setting out on a journey without a map. By aligning to a definition of ready, each slice becomes a confident step forward rather than a gamble that risks slowing progress. Anti-patterns in decomposition serve as important cautionary tales. One common pitfall is layer-only builds, where work is decomposed by technical components rather than by value, delaying feedback. Another anti-pattern is reducing a story into a mere task list without preserving user outcomes, which may give the illusion of progress while delivering nothing testable. Perhaps the most dangerous is the Big Bang approach, where teams resist decomposition altogether and attempt to release large features in one go. These patterns suppress feedback until late, magnify risk, and often lead to expensive surprises. Reflecting on these pitfalls reminds teams why decomposition exists in the first place: to reduce uncertainty, accelerate learning, and preserve intent through visible increments. Avoiding anti-patterns requires discipline, but the reward is a steady flow of validated progress that benefits both the team and the users they serve. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Story-to-task breakdown is where decomposition zooms in from the level of a thin slice to the collaborative details that make it executable. A user story may describe an outcome like, "As a shopper, I can add an item to my cart," but to bring that to life, the team breaks it down into tasks such as design changes, coding, writing automated tests, configuring telemetry, and documenting behavior. Importantly, these tasks all roll back up into the same story and the same acceptance criteria, ensuring coherence. Without this discipline, tasks risk scattering into disconnected technical fragments. The goal is not to dilute the story's outcome, but to mobilize diverse skills around delivering it. Teams that handle story-to-task breakdown well discover that cross-functional collaboration increases because each person understands how their contribution fits into a shared acceptance, rather than being siloed into unrelated to-dos. Acceptance criteria are never static. They evolve as stories and slices unfold. In decomposition, this means that successive slices tighten and expand criteria as understanding grows. For instance, the first slice of a login feature may have criteria such as user can enter valid credentials and gain access. Later slices might extend criteria to include error messages for invalid credentials, lockout after multiple failed attempts, or multi-factor authentication. This staged evolution prevents teams from overloading early slices with exhaustive conditions, yet ensures that rigor increases over time. It also helps teams align testing with learning, since each increment clarifies what still needs to be proven. Evolving acceptance criteria ensures coherence across slices, so the system builds in completeness gradually. Far from being a sign of instability, this evolution reflects agile learning in practice, turning acceptance into a living agreement rather than a fixed contract. Contract-first decomposition is especially powerful when interfaces and integrations are involved. Instead of waiting until code is written to negotiate expectations, teams define consumer-driven contracts early, capturing what an application programming interface should provide and how consumers will use it. These contracts then serve as testable, versioned agreements that evolve as slices are delivered. For example, if a payments API must return confirmation codes in a specific format, that detail is codified up front, allowing consumers to write tests even before full implementation exists. Each slice can then implement more of the contract, while validation happens continuously. This approach reduces integration risk, accelerates feedback between producers and consumers, and avoids costly misalignments discovered late. Contract-first decomposition demonstrates how slicing is not only about functional behavior, but also about the agreements that allow systems to collaborate safely as they grow. Spikes are another form of decomposition, but their role is exploratory rather than directly productive. A spike is a time-boxed investigation designed to answer a question or reduce uncertainty, such as testing whether a cloud service can handle certain encryption methods or whether a machine learning library meets latency requirements. The critical point is that a spike delivers a decision or a prototype, not production code. Its outcome is knowledge that informs future slices. To prevent spikes from drifting into endless research, they are explicitly time-boxed and closed with a clear gate. Either promote what was learned into implementation or discard it if unsuitable. This promote or discard discipline ensures spikes serve learning without becoming a hidden backlog of half-finished features. By treating spikes as slices of discovery, teams honor the agile value of experimentation while keeping the main flow of delivery intact and predictable. Happy Path First strategy is a decomposition approach where teams begin with the simplest, most common flow, the happy path, and then add error handling, retries, and edge cases as later slices. This strategy delivers value quickly because the most frequent use case becomes available early. For instance, in building an online payment feature, the happy path might be a successful credit card transaction with valid credentials. Once that works, additional slices can address declines, expired cards, or network failures. The advantage is that teams do not delay progress by waiting for every possible contingency to be implemented. Instead, they ensure the primary flow works while incrementally layering robustness. This method both accelerates user feedback and avoids unnecessary complexity early on. It also provides natural checkpoints where riskier or less common scenarios can be validated in isolation, rather than complicating the first delivery attempt. The walking skeleton approach pushes decomposition even further by creating the thinnest possible thread of a working system that spans all components. It might do very little, but it proves that the architecture can support integration across the full stack. Imagine a health tracking app where the first slice allows a user to submit a single heart rate reading through a mobile interface, process it through a minimal backend, and store it in a database. This skeleton establishes the pipeline, even if it lacks features like charts, alerts, or multi-device syncing. By validating integration risks first, the walking skeleton provides a foundation upon which depth can be built safely. Teams gain confidence that the architecture holds together, reducing the chance of discovering structural flaws late. This method reflects the agile principle of embracing uncertainty early, choosing to learn whether the bones of the system can support growth before adding muscle and skin. Date-constrained decomposition acknowledges that sometimes external deadlines cannot move, such as regulatory compliance dates, product launches, or contractual obligations. In these situations, teams must backplan from the immovable event, flexing scope by decomposing into smaller outcome-true slices. For example, if a new data privacy regulation requires evidence by a set date, the team may prioritize slices that provide audit logs and reporting for the most sensitive data first, leaving less critical cases for later. This ensures that quality is preserved by focusing on essentials, rather than cutting corners under pressure. Date-constrained decomposition reframes the problem. Instead of doing less well, teams do smaller pieces of the right thing, sequencing value to meet deadlines responsibly. This approach demonstrates that agility is not only about speed, but about aligning slices to reality, while still maintaining integrity and predictability. Runtime configurability through feature flags offers a way to make slices safe in real-world conditions. A feature flag is a toggle that allows a team to expose new functionality selectively, to testers, to a subset of users, or to no one at all, while the code still exists in production. This makes decomposition less risky because each slice can be deployed early and tested under live conditions without forcing exposure to all users. For example, a new recommendation engine might first be enabled only for employees or 5% of customers, allowing observation before full rollout. Feature flags also enable quick rollback if issues appear. In this way, runtime configurability supports decomposition by making each slice a safe experiment. It reduces the fear of shipping often, turning incremental delivery into a continuous, low-risk practice rather than a high-stakes event. Observability per slice underscores that every increment is also a measurement opportunity. Delivering a slice without the ability to observe its behavior limits learning and reduces the value of decomposition. By including logs, events, metrics, and dashboards with each slice, teams can verify not only that the slice works but also that it contributes meaningfully to outcomes. For instance, when releasing a new search feature, observability might include telemetry on query success rates, response times, and user engagement. These insights help teams adjust quickly and validate whether the slice actually achieves its intended value. Building observability into every slice also prevents last-minute scrambles to add monitoring at release. Instead, evidence accrues continuously, making each increment a feedback loop rather than a blind drop. Observability turns decomposition into a scientific practice of hypothesis and validation, grounded in real data at every step. Compliance-ready decomposition ensures that regulatory or audit requirements are not deferred until the end, when assembling evidence is hardest. Instead, each slice captures necessary approvals, traceability, and documentation as it is delivered. For example, when releasing a healthcare application slice, audit logs of patient access might be included from the very first increment, rather than waiting until the system is nearly complete. By embedding compliance early, teams reduce the burden of big bang audit preparation and avoid the risk of non-compliance surprises. Compliance-ready decomposition also reframes governance from being a blocker to being a continuous partner in delivery. Rather than a separate layer of work, compliance becomes integrated into each slice, ensuring that value and evidence accumulate side by side. This makes the system safer, more transparent, and easier to certify, reflecting the agile value of working solutions aligned with real-world constraints. Remote refinement practices are increasingly relevant in distributed teams. Decomposition in such environments requires clarity without overloading calendars with meetings. Practices such as sharing pre-reads, gathering asynchronous comments, and keeping live sessions concise help maintain shared understanding while avoiding meeting sprawl. For example, a team might circulate a proposed decomposition of an epic via a shared document, collect written input across time zones, and then use a short live session to resolve open questions. This rhythm ensures that decomposition remains collaborative even when physical proximity is lacking. Remote refinement acknowledges that clarity is a product of preparation, not just discussion. By structuring input and alignment around decomposed slices, teams reduce misunderstandings and maintain momentum without draining energy through constant synchronous sessions. In this way, decomposition supports not only the flow of work, but also the health of distributed collaboration. Effectiveness checks ensure that decomposition is not treated as dogma, but as a practice that should demonstrably improve outcomes. Teams track measures like cycle time distribution, work-in-process levels, and escape defects to confirm that slicing actually leads to better flow and quality. If slices are too thin, they may create overhead without value. If too thick, they may defer learning. By examining metrics, teams calibrate decomposition continuously. For example, if cycle times remain unpredictable, it may suggest that slices are still too large or poorly defined. Conversely, if quality drops, it may reveal that non-functional slices are being neglected. Effectiveness checks close the loop by making decomposition a reflective process. It is not enough to slice work. Teams must also validate that their slicing improves delivery, learning, and value. This meta-level of inspection reinforces the agile mindset of adaptation through evidence. Recomposition and refactoring are necessary to clean up the temporary seams introduced during decomposition. Techniques such as stubs, feature flags, or adapters allow slices to progress independently, but leaving them in place too long can clutter the codebase. Once learning stabilizes and features mature, teams remove temporary scaffolding, integrate flows, and simplify structures. For example, once an external system is available, a stubbed integration is retired. Similarly, once a feature is fully rolled out, its flag may be removed. This recomposition phase ensures that the system does not accumulate technical debt in the name of agility. It acknowledges that while decomposition requires temporary scaffolding, long-term health requires consolidation. By treating recomposition as an intentional act, teams preserve the benefits of slicing without sacrificing maintainability. This balance between temporary flexibility and permanent clarity is a hallmark of sustainable agile delivery. Pattern library curation captures the institutional memory of effective decomposition techniques. Each time a team successfully slices an epic into valuable increments, those examples can be recorded as templates for future use. For instance, a team that learns to decompose user registration into happy path, error handling, and multi-channel access can document that pattern for others. Over time, this creates a shared resource that accelerates decomposition by offering proven starting points. Pattern libraries reduce reinvention, spread best practices, and create a shared vocabulary across teams. They also encourage reflection, since teams must articulate why a pattern worked and when it applies. This curation turns decomposition from an individual skill into an organizational capability, raising the overall quality of delivery. By drawing from a library of successful approaches, teams can decompose faster, more consistently, and with greater confidence that their slices will yield real outcomes. In conclusion, decomposition in Agile practice is about far more than breaking work down. It is about breaking it down in ways that preserve intent, reduce risk, and maximize learning. Part 2 has shown how techniques such as story-to-task breakdown, contract-first design, happy path-first sequencing, walking skeletons, and feature flags create safe, observable slices that deliver value continuously. Supporting practices like observability, compliance-ready increments, remote refinement, and effectiveness checks ensure that decomposition is not only structured, but also adaptive. Recomposition and pattern libraries demonstrate that decomposition is cyclical, feeding forward into better future practices. Together, these techniques illustrate how large, complex initiatives can flow as safe, measurable increments that retain coherence. The art of decomposition lies in balancing creativity with discipline, cutting work not just smaller, but smarter, so every slice advances learning and value while keeping the larger vision intact. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.